Well, hey again, everybody, Mr. Taylor. Let's go ahead and work the very last lesson in Unit 6. So as you recall from the last video, we were trying to understand what we mean by means absolute deviation. And we did work through to show you how it is computed. Today, let's take a look at how we use this mean absolute deviation. So your learning objective is you will use the mean absolute deviation to answer statistical questions in real-world situations. Recall your vocabulary: measure of center, mean, measure of variability, mean absolute deviation. Well, at this point, let's answer the famous question, why am I learning this? When will I use it? And for the most part, I guess I want to answer by saying you're not learning math to utilize math in the 8th and 9th grade. You're learning math to utilize math in real world situations, in job type situations, even shorter term than that, in college. So statistics is a very important tool for you to learn, especially if you're going to get into the business element, even owning your own business. So saying that, the mean absolute deviation can be used to answer statistical questions in the real world. Many of these questions may have implications for the operations of various businesses. Before we get into the chicken farmer, let me say this. There are times when I give a test or I'll give a quiz and I'll grade it. Well, of course I do put the grades up on the bulletin board according to student numbers, so everybody can look and see exactly what they did. But in order to give me a good picture of how the class did overall, I'll use means absolute deviation. And what I do is I'll take the average of the class and I'll apply that average to every individual student's grade and see the variability. See whether or not you're close to the average or you need help with tutoring or whatever. So that's just for me to put my little 2 cents in and show you how I use means absolute deviation. Because in some cases, some students may make 100, whereas some may make 40. So that's going to skew the actual data if I'm not analyzing this data correctly. All right, let's talk about what the author was talking about. So he says a chicken farmer wants her chickens to have all about the same weight. That's the way I am about the grade. I want everybody to have, if it's an 80, I want everybody to be around that 80. I don't want an 80 and a 25, or I don't want a 100 and a 50. I want everybody to be around that 80. So she's trying 2 types of feed to see which type produces the best results. All the chicken in pen A are fed premium growth, and all the chicken in pen B are fed maximum growth. So she records the weight of the chicken in each pen in the tables below, and the question is, which chicken feed produces less variability in the weight? Okay, so here's what we're looking at. Premium A growth 5.8, 6.1, 5.5, 6.6, 7.3, 5.9, 6.3, 5.7, 6.8, 7.1. So how many chickens did she weigh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So she compared 10, or weighed 10 chickens in pen A, and in pen B, 1, 2, 3, 4, 5, 6, 7, 8, 9. She had 10 as well. So 7.7, 7.4, 5.4, 7.8, 6.1, 5.2, 7.5, 7.9, 6.3, and 5.6 was the weights. Okay, so step one, here's what the author say we need to do, is find the mean. So means absolute deviation. Let's find the mean weight of chicken at each pen. So we add each one of the 8 weights up. And I know you recall that when you're adding decimals, you place number under number. So that'll be decimal under decimal and the 8 and the 1 underneath each other. And that way you add like that. So anyway, we add these numbers up, we get 63.1. It's around to the nearest tenth. So when we divide 63.1 by 10, we'll get 6.31 to the nearest tenth. That 1 is less than, let me put this up here for you so make sure we get it. So this is going to give us 6.31. We're going to drop the 1, and then that's approximately 6.3. So that's what happened there. The same thing with this one. We add these up, and we're going to get 66.9 divided by 10. We will get, just move that decimal place, guys. When you divide by 10, just move it over 1 to your left, and you'll get 6.69. And you're going to move, since the 9 is greater than 5, we're going to increase to 6 to 6.7. So that's how that's done. Okay, let's try to move a little bit faster. Step 2 says find the distance from the mean for each point. So when we subtract, what is the first one that we looked at? 6.3 and then 6.7. So here the means is, so let's put mean is 6.3, and on this one the mean is 6.7. So if we subtract 6.3 from, so here again, this is 6.3 and 5.8. This is 6.3 and 6.1. This is 6.3 and 5.5, and we're subtracting, guys, okay? This is 6.6 and minus 6.3. And you notice what I'm doing, I'm going right ahead and taking the smaller number and subtracting from the larger number so we don't get stuck with the incorrect sign. So here I have 7.3 minus 6.1. I have 6.3 minus 5.9. I have 6.3 minus 6.3. I have 6.3 minus 5.7. I have 6.3, well, let's go 6.8 minus 6.3, and 7.1 minus 6.3. And that's going to give us our mean distance here. So then you should know what we're going to do next. So we do the exact same thing here. We're going to subtract from each one. We're going to subtract 6.7. Okay, and that's going to give us our distance from the mean. Okay. So now we want to calculate the mean absolute deviation. So we add up what we subtracted, divide by the number of chickens that we had, we will get 5.1, divide that by 10, or just move the decimal place over one time, and we will get 0.51. It said to the nearest tenth, so that's 0.5. Do the same thing here. We're going to add all these up. We'll get 9.7 divided by 10. We're just going to move the decimal place over once. And then that means if we're rounding to the nearest tenth, 0.9 will become 1.0. So this is saying that if you were to look at the difference between the two, 0.5 and 1.0, 0.5 is less. So that means that it produces the less variability in the weight, which is what she was looking for, and PNA did that. Okay, now here's what I want you to do. I want you to stop the video. See, can you work this problem? Again, what we're going to try to do is you need to add up, find the mean. So let's make sure we understand what we're doing. Number one, find the mean. And then number two, you're going to subtract. And you're going to subtract the mean from each cup of coffee. Okay, and then once you do that, number three, you want to find the means of that. Of what you subtracted. Okay, and then you can answer the question, which one is smaller. So go ahead and stop the video, do that, come back when you're done, and check your answer. All right, so it says two baristas at a coffee shop each served 10 large coffees actually. The amount in each large coffee is shown below. Which barista coffee showed less variability? What in the world is a barista, Mr. Taylor? Those are the people you go to, where you guys go, wherever you go to buy your coffee, and they make the coffee and sell it. I think Starbucks is famous. Those people behind the counter, that's what they are. So anyway, you will take the actual 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different cups, and you will add them up, and hopefully you got 199.9 divided by 10, and you will get 19.9. Oh, excuse me. You will get 19.9. Here, you add these up and divide by 10, and you should get 20.01. Okay, so if we round these up, you can round this to 20, you can round this to 20. So now it asks us to find the actual MAD. So in order to do that, then we go ahead and subtract. So I actually use 19.9 and subtract. I got 0.8, 0.2, 1.0, 0.3, 1.0, 0.4, 0.7, 0.5, 0.4, and 1.0. When I added those up, I got 6.3 divided by 10. I got 0.63. I round that to the nearest tenth, and I got 0.6, which is what the actual author said that they got. And for B, I did the same thing. I added the coffees up to find the means. When I did that, I got 20.01. Subtract from each one, I got 0.1, 0.4, 0, 0.5, 0.2, 0, 0.1, 0.3, 0.1, and 0.4. Add those up, I got 2.1 and divided by 10, and I got 0.21, which is actually 0.2. So to answer the question, the MAD in the first one is 0.6, the MAD in the second one is 0.2, which means that B shows less variability, and it asks us, will a smaller means always signal less variability? And the answer is no. So you can go back and look at the Explorer activity and you'll see there. All right. As always, if you have any questions, please contact me. And if you haven't subscribed, please do so. I appreciate your comments. I'll talk to you soon.